Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In this particular video, we will be discussing some things related to representation of data, and my focus in this particular video is specifically about the reasoning part. There could be reasonings related to a mean and standard deviation. There could be reasonings related to median and interquartile range. It could be about advantages or disadvantages regarding stem plot versus box plot. So, lot of different scenarios like this, or maybe they could be talking about outliers. So, let's get started. First of all, when we talk about mean and standard deviation, that is the same thing as talking about median and interquartile range. When we will use the word median or median, mean or median, we would specifically be talking about the average value, the typical value. When we talk about standard deviation or variance or interquartile range, this is a measure of dispersion, measure of variability. There could be a question related with a median and interquartile range or mean and standard deviation. For example, comparing the two components of AS level math. It could be the comparison between P1 and S1. So let's say a person scored 78% in P1 and he scored on average 70% in S1. This could be the mean mark, this could be the median mark. What about the measure of dispersion, the variability? The SD for P1 is 12%, the SD for S1 is 17%. Now, when I'll compare these two, I won't say one is higher, one is lower, because we won't state the obvious. Remember my words, we won't state the obvious, because that is so obvious. Why state that? You have to write in the context of this question. So we would say on average, students performed better in P1 as compared to S1. So when the examiner will look at the wording of on average, automatically he would think that we are talking about mean and standard deviation later on, or we are talking about median and interquartile range. So for right now, on average, it refers to mean and median. Similarly, when I'll be comparing the standard deviation or the interquartile range, and that is a measure of dispersion. In S1, it's more, in P1, it's less. The performance of students in S1 exam was more varied, more dispersed as compared to the performance in P1. So now the word dispersed or varied, that automatically refers to either standard deviation or variance, which is a square of standard deviation, or we could be talking about interquartile range. Remember, they would be asking in pairs mean and standard deviation, or they could be asking about median and interquartile range. So that's how this is done. High standard deviation means too much dispersion and less consistency. Low standard deviation means less dispersion, more consistency, more reliability. Now, this is the terminology that you have probably seen, which is measures of central tendency. There are three measures of central tendency. That is mean, median, and mode. What about the mean? Mean is the average. If we use the symbol X bar, that is sigma X over N, if we talk about raw data. And let's say if we talk about frequency distribution, so X bar is sigma Fx over sigma F. Now, average takes all the values into consideration, but it is distorted by extreme values. It won't be unrealistic. It won't be realistic. Actually, it would be unrealistic. What about median? Value that occurs in the middle. And for that, we have to make sure that things are arranged in ascending order. That is the rule. 50% of the distribution lies below the median, 50% of the distribution lies above the median. It's the middle value. What is mode? It's just a general idea rather than a mathematical concept. And if we talk about a class interval, for example, x lies between 10 and 19, so we would talk about the modal value or the modal class. Measures of dispersion, standard deviation is a measure of dispersion, variance is a measure of dispersion, interquartile range, which is upper minus lower quartile, range, which is the highest value minus lowest value. So measure of central tendency, mean, median, mode, measures of dispersion, standard deviation, variance, which is square of standard deviation, interquartile range, and range. Now let's look at this question. It says a company runs two machine lines or manufacturing lines A and B, which makes rods 2 centimeter in diameter. Random samples are taken from each from manufacturing line A, manufacturing line B. The results are summarized below. The mean diameter is the same. The standard deviation of one is higher. So this is 0.050 and this is 0.015. So basically we are comparing 15 with 50. It says the company wishes to choose one of the lines. State which one would you recommend them to choose or close. Give one reason for your answer. Which one do you think? So the secret lies over here. Low standard deviation, less dispersion, more consistency, more variability. So this is low SD. This is high SD. Low SD means more reliability. So I think I'll go ahead and choose this one from company A, and that is what is outlined over here. The next question, actually it's a concept. What are these? You have already studied. These are different box plot. We know that this is the lowest value, this is the highest value, this is lower quartile, this is median, this is upper quartile. What do we observe? Let me just highlight it a bit. So let me choose a red marker over here. So this is the right hand whisker, and a green marker over here. This is the left hand whisker. And what else do we see? We see that the median is in the middle. Just the observation for right now and the conclusions on the next page. What about over here? Now the median is closer to the lower quartile, and over here this region is a lot more. This region from median to upper quartile, that is the majority. And what about the other one? This is lower quartile, this is lower quartile, this is median, this is upper quartile. This time, this region is too high. This is a very, very big region. Let me choose a orange marker over here. This is very much between lower quartile and median. Over here, the region was very much occupancy between median and upper quartile. Now, what is the conclusion? And one other thing that we observe is that this line is a lot longer. Over here, the two lines are of equal length, but the difference between median and upper quartile is much more than between median and lower quartile. And this is the opposite. Now, let's look at each one of them. Now, we are talking about skewness. What is skewness? Skewness is highest value minus the right hand whisker, which is Q3, highest value minus the upper quartile, that is the length of the right hand whisker. So let me write over here, right hand whisker. This is, let me choose another marker, right hand whisker, that is highest value minus upper quartile, left hand whisker, that is lower quartile minus lowest value. So these are the whiskers. That's the whisker. That is the whisker. This is the box. That is why it is named the box and whisker diagram, also known as box plot. So over here, what we observe is that this length and this length is the same. The median is in the middle. So this is a symmetric distribution, just like normal distribution. The left hand whisker and the right hand whisker is of equal length. Over here, the right hand whisker is slightly bigger. If you look at it, not in this diagram, but in general, when it is positively skewed, we know that this region is much more as compared to this. So the difference between median and upper quartile is more. It's mostly on the positive side, as we can say that let's say, for example, a test is taken and many people scored on the better side, on the higher side. So therefore, I would say that this is positively skewed. And usually the right hand whisker is of greater length. Over here, it's not so, but just this much would suffice that this is positively skewed. On the other side, let me mark it with a green color. On the other side, if we talk about this region, between lower quartile and median, that is the majority of the area, and the left hand whisker is greater, so this is negatively skewed. So for 1 mark, they can ask this question whether it is positively skewed, is it symmetric, is it positively skewed, is it negatively skewed. That is the depth to which the examiner can ask this question related to skewness. So now let's look over here. This particular question, it says a group of children played a computer game which measured the time in seconds to perform a certain task. A summary of the times are taken by girls and boys in the group is shown below. So let me just highlight this. Let me make it bigger. So this is for the girls, and this is the data, the minimum, the lower quartile, the median, the upper quartile, and the maximum. And for the boys, this is the data 1, 2, 3, 4, 5. It's a 5-point summary. What are they asking? On a graph paper or on a grid, draw 2 box and whisker plot, which is called comparative box plot, in a single diagram to illustrate the times taken by girls and boys to perform this task. State 2 comparison. Now, first of all, I have not drawn the box plot as yet. That is the basic thing because my focus is on the reasoning. For girls, the lowest value is 0.5. And what about the length of the whiskers? The length of the whiskers, this one is greater. The right hand whisker is greater. That is 4 unit. And also this region is more. It's more between upper quartile and median. Therefore, it is positively skewed. And the second thing is that for boys, the whiskers are not of equal length. Again, the right hand whisker is more, but now let's compare based upon this. These two are equal, therefore symmetric distribution. So if there is a dilemma between the whiskers versus this difference, so we would focus on this. If the difference between median and lower quartile and median and upper quartile, if this is the same, we say it is symmetric distribution. So the distribution of boys is symmetric, whereas the distribution for girls is positively skewed. So this is 1 mark. What else is the comparison? The comparison can be made on the basis of interquartile range. There is more dispersion in boys. Why? Because in boys, 11 minus 6 is 5 and 9 minus 5.5, that is 3.5. So there is more dispersion in boys. The time taken to complete a certain task, there is more variability. And what about the median? The median value for girls is higher, the median lower, and the median value for boys is higher. That means girls on average are taking less time to complete, or boys are taking more time compared to girls. So that is the knowledge that we would apply. So let me list it down. One piece of reasoning would be based upon median. One piece of reasoning would be based upon IQR, and the other one will be based on skewness. So that is how we have to answer this. Now let's look at this. This question was also discussed in class. There are 11 people and these are the salaries. This is the abnormal value, the value that does not fit this criteria. The rest of the salaries, they are very, very close by. But this one is just out of the league. So now it says choose and calculate an appropriate measure of central tendency, whether it's mean or median or mode. To summarize, explain briefly why the other measures are not suitable. So first of all, I would say the mean is not suitable. Why? Because it takes all the values into consideration. Because 352 is such an outlier, the answer would be an unrealistic mean, or mean is distorted by extreme values. So we would drop this out. What about the mode? Mode is just a general idea rather than a mathematical concept, so just discard it. So what is left? We are left with median. We arrange the data in ascending order. This is the middle value. 50% of the distribution lies below the median, 50 lies above the median. So the correct answer over here is the median. Now, one other issue that comes is the comparison between raw data and frequency distribution. Now, let's say this is the raw data. I calculate sigma x, I add up all the values, I divide by how many they are, and this is my answer for the mean, which is exact. On the other hand, based upon the same data, I make frequency distribution. This is grouped frequency distribution. That means I have created class intervals. And based upon the mid value, I calculated the mean. The mid value over here is 4.5 and 14.5 and 24.5 and 34.5 and 44.5, and apply this formula sigma fx over sigma f, and this mean is coming out to be 22.23. So this is an estimate, this is an exact. Raw data will give us exact, frequency distribution will give an estimate. Why? Because we are assuming the data to be evenly distributed in a class interval, which may or may not be the case. That means between 0 and 9, I'm using the value 4.5. And between 0 and 9, I have these values 1, 2, 3, 4, 6, and 7. So 4.5 is somewhere over here. There are more values lesser than 4.5 and less values greater, but our calculation is based upon 4.5. So therefore, we are making an assumption which may or may not be true. What is the assumption that we make? We are assuming that the data to be evenly distributed, which may or may not be the case. So raw data, exact, and frequency distribution, estimate. Another question in which a table is given, a frequency distribution is given. They are asking, state which time interval in the table contains the median. So they're not asking for the median itself, they are asking which time interval and which contains the upper quartile, and then it's a histogram and calculate an estimate time to travel. I think this is something else that is pasted over here. So let me just remove this thing. So now over here, what we do is that there are 112 people. So let me do the division. That is 112 divided by 2. That is how much? That is 56. So let me look for the 56th and the 57th value, because that average will give us the median. Okay. So now over here, let me add it up. This is 19 plus 12. That is 29, 31. So up till here is 31. 31 plus 28, 39, 59. That means the 56th and the 57th value is over here. So the 56th value is also here, 57th value is also over here. Therefore, they are asking about which time interval. So the time interval is 15 till 20. Now, let me keep adding it up. And if I add 59 plus 20, 79 plus 2, which is 81 up till here, and 81 plus 18, 89, and 99 plus 13 definitely is 112. So let me take 3/4 of 112. So 112 divided by 2 is 56. And let me add 28 more to it. So 6 and 8 is 14. And this is 84th. So the 84th value will give me the upper quartile. So where is the 84th value? 81st value is still here, therefore 84th value is over here. So this thing contains the upper quartile, and that is what I'm focusing on. This one we know about the lower quartile, the median, the upper quartile, the interquartile range. So this is just a graph, a CF graph, and I have calculated the following things. It is related to the next question. And we know that we calculate it for the 50% of the value, 75% of the value, 25% of the value. So therefore, this is upper quartile. Therefore, this is median. Therefore, this is, this one is lower quartile, and this is upper quartile. So now, what is the question all about? Let me highlight it with a highlighter. The CF graph shows the annual salaries in thousands of euros of a random sample of 500 adults with jobs. Plotted lower salary is 5,000, highest salary is 80,000. On a graph paper, draw a box plot that is basic. Comment on the salaries of the people in the sample. Now the comment will be based upon the interquartile range. I'll just write it down. It can be based upon interquartile range. It can be based upon median. It can be based upon skewness. Now, let me focus on the third part. It says an outlier is defined as any data value which is more than 1.5 times the interquartile range above the upper quartile. That means take the upper quartile and add 1.5 times interquartile range. That is an outlier. Also, there is another outlier, or more than 1.5 times the interquartile range below the lower quartile. So another outlier is interquartile range, again 1.5 times IQR, but now it's below. So we have to subtract, and that's the second outlier. So this is the lower outlier, this is the bigger outlier. Now it says how high must a salary be in order to be classified as an outlier? Show that none of these salaries is low enough to be an outlier. Now keep in mind, this is the lowest salary, this is the highest salary, and we have these three things, 15, 18 and 26. This is in thousands of euros. So therefore, the working is right over here. The lower quartile is 15. The upper quartile is 26. Interquartile range is 11. 1.5 into 11. Subtract it from the lower quartile, and that gives me negative 1.5. Of course, you cannot have a negative salary. You cannot give money to your employer. So negative salary is not possible. Upper outlier, that is upper quartile plus 1.5 IQR, 26 plus this value, that is 42.5. That is 42,500 euros. So they are saying how high must a salary be in order to be classified as an outlier. So 42,500 euros. That is the answer. And low enough, there is no outlier because the outlier value is negative. Now, this one is about the advantage and disadvantage of box and whisker plot. That is what I'm focusing on. And that is this thing, that the advantage of box plot is the disadvantage of stem plot. The advantage of stem plot is the disadvantage of box plot. So we know that in a box plot, this is also known as, let me write it down, this is also known as 5-point summary. Why? Because you get the lowest value, you get the lower quartile, you get the median, you get the upper quartile, and you get the highest value. So 1, 2, 3, 4, 5, these are the 5 values. At a glance, you get the 5-point summary, and you also get the skewness. Don't forget the skewness. It could be positively skewed, negatively skewed, and so on, which is not possible in a stem diagram. What about the advantage of stem plot over the box plot? The original data is preserved, it is not wasted. So that is all about the different reasonings that come in the S1 paper, which is paper 5. I hope you enjoyed the lecture. And do let me know in the comment section which are the topic you want me to focus on and how helpful was this particular video. Till the very next class, take care from Mathematics with Shahab Yaqub.